So we have imported the data HR analytics from Analytics Vidya. Analytics Vidya, HR Analytics Hackathon. We have imported the train data and test data. We have done the importing, and then we are doing some basic descriptive statistics on the numeric variable called average training score. Okay. So what you got here? Negative kurtosis and closer to zero skewness. Negative kurtosis and closer to zero skewness. All right. Now, create histogram, box plot, and density curve for the variable average underscore training underscore score. Create histogram, box plot, and density curve. Dot plot HR train dot average training score dot plot in brackets of plot kind is equal to single quote hist, HIST hist. So the pandas plot. HR train dot average training score dot plot kind is equal to quotes hist. You can see the command on the screen. You can see the plot code of histogram. So how does it look like? Does it look like a normal distribution? No, right? I think there are two peaks. We know only when the density comes. Now do the box plot. For box plot, kind is equal to box. Same command, kind is equal to box. Is for box plot. We can copy paste the commands. Control C, Control V. All Windows commands will work. So HR train dot average training score dot plot kind is equal to box comma vert is equal to false. You'll get a horizontal box plot. See, yesterday we didn't get a proper box plot. Today we are getting a proper box plot, right? You can see, right, the box is wide means we might have double peak. If the box is very wide, you will have something like, now do the density plot, you will see. Do the density plot, you will see, but there are no outliers because there are no dots, right, on the end. So there are no outliers, but the median is to the left. Positive skewness. See, how do you identify skewness is, this is smaller, right? Compared to this, that means the box is towards the left side. The box is towards the left side. And there are no outliers. Do the density plot. HR train dot average training score dot plot kind is equal to density. See, there are multiple peaks, not two. Right? This is not normal distribution. This is not normal distribution. Completely not normal distribution. But 0.45 skewness is showing okay. So this is average data, na? That's why it is looking like this. Okay. Now I want you to find out, is there a relationship between age and average training score? I want you to find out the relationship between age and average training score. How will you find out? Bivariate, covariance, correlation, and scatter plot. Age and average training score. Is there a relationship between age and average training score? Very started. No problem. Open the YouTube notes. Forget all these things. Close. You don't need to do anything. It's already there. See? Untitled. 25 minutes ago you have done this, right? Click on this. It is auto saving. It automatically saves. See, everything is you have to run now. Just all you have to do is go to cell, run now. That's all. You don't need to do anything. Age. Now describe. B-E bracket. And shift plus N. Right? Now come to HR train. Tab. Dot AVG tab. Tab, not dot. Very lengthy name, tab. Dot describe. DES and tab. Yeah, it's done. Yes, very good. And then brackets. Done. Shift plus enter. Now that this is right. Now print. print, open bracket, HR train dot avg tab dot SKE tab. SKE tab. Brackets. After school, there are two brackets, null brackets. Now, every brackets, every function should have brackets. Now run it. No, next line. Here only you type the next command also. Print. Open bracket, HR print. Dot avg tab. Dot KUR and null brackets. KUR tab. KUR. Tab. Cut. KUR brackets. And brackets. Now the plotting data. You want the plot, histogram, box plot, and density plot. See, this is the command for histogram. What did you guys bivariate? Relationship is there? Yeah. What is the covariance? Positive or negative? Covariance is negative. Then how can you put the relationship? No relationship. What about correlation? Negative. That means there is no relationship. Scatter plot? How to? Which one? Scatter plotter. I have given you yesterday's notebook. Open it. In that, I have given you the graphs for correlation coefficients. So this should be negative means opposite, like this. What you call right to left diagonal, upwards. That means no relationship. You check in the plots, yesterday's plots. See, it matches this plot, right? I given you the plots now, yesterday's notes. This matches exactly this. That means no correlation. So it's there. You refer. That's why I'm asking you to keep yesterday's notebook open, so that you can refer to that notes and interpret and analyze. You can keep up to 5 notebooks open. You will not have any problem. Only thing is the notebook should be named properly, so that you don't get confused which notebook is what. So there is no relationship between age and average credit score.
Are we going to submit this?
No. Doing lots of analysis. Getting those blocks from F capital false. False F capital. Yeah, that's syntax. False and true F and T capital. See the color coding. If you type it correctly, you get it as green color. That's another advantage in Jupyter Notebook. You get the color codes. If this is black, means you have done a mistake. It is green color, right? Then you have to do the density plot. Now I will also do HR train double square bracket single quote age comma single quote AVG underscore training underscore score dot COV. Oh, I made a spelling mistake. Yeah, here, density. Covariance. Got it? Covariance, negative. Correlation, same command you will copy. Control C, I'll paste it down. COV to CORR. Correlation also negative. Then HR train dot plot x is equal to age, comma, y is equal to avg underscore training underscore score, comma, kind is equal to scatter. No relationship, right? Back guys, you are able to see the notebook, or you want me to increase the font? Visible? Huh? Okay. So scatter plot matches the yesterday's plot. Always, if you have any doubt, go to Google Images, correlation plots, and compare the existing plot with the plots there. If you have any problem in understanding what this means, this plot means what? We got a plot like this, right? What does this plot means? In yesterday's notebook, I have given you the correlation plots. See, this matches this pattern, right? What is this pattern? No correlation pattern. Right? You'll find a lot of things on Google Images. Not that you have to refer this only. You can refer to any Google image of correlation image and understand the correlation pattern. If you are finding difficult to remember. Right? This is clearly no correlation between these two variables. The correlation is also negative, which says actually 0, right? Correlation is 0. -0, right? Correlation. Covariance and correlation. So this is all we have to do on numerical data. Whatever we have done till now is on numerical data. But in real-time world, you will have 70% non-numeric categorical data. In real-time data science, we see more than 70% non-numeric categorical data. Text. Non-numeric categorical data like text. If you look at our data here, we have text data points. I didn't do head down. HR train dot head, just to see. See, we have text variables. What are the text variables? Department is a text variable. Region is a text variable. Education is text variable. Gender is text variable. Recruitment channel is text variable. Now you see ratings, 1 to 5 rating. Can you treat them as numbers? Is rating 1 equal to rating 5? No, right? You can't treat them as numbers. You have to treat them as categories. Employees who got rating 1, they are different. Employees rating 2. So rating scales, you can't treat them as numbers. They will be in numbers. Rating scales typically between 1 to 5 and 1 to 10. Which one? Error. Which error?
Excel have an error rate in that table.
Okay.
Are they treated as numbers?
That depends whether the error rate is in percentage or what format. Percentages means you can treat them in numbers.
Decimals?
Yeah, decimals also numbers. See, logic is, can you calculate rating scales mean? You can calculate. You can calculate average of rating scales. But is there a 2.3 rating scale? Is there a 3.6 rating scale? Because mean will be like that only, right? Mean will be a decimal number. Mean will be a decimal number. Can we have a rating scale in decimal? No, right? We have 1, 2, 3, 4, and 5, which indicates you can't treat them as numbers. Years, you can't treat them as numbers. Months, 1 to 12 months will be there, right? You can't treat them as numbers. So within numerical data, sometimes you will find categorical data. You need to have that subject knowledge and idea to separate those variables. Okay. Sometimes already gender is coded. 0 is the female, 1 is male. Here it is not coded. Sometimes some data, it is already coded. Gender is 0 and 1. 0 means what? Female. Alphabetically, female comes first, male later. 0 is female, 1 is male. Can we treat them as numbers? We cannot. So you have to look at the variable and understand. Right? So always remember, all numeric data will not be numeric. Within numeric data, there might be categorical variables. You need to separate them within numerical data. Okay. Now, here we have two such variables. Awards 1, 0 and 1. Awards 1, 0 and 1. 0 means no, 1 means yes. There's a variable called awards 1. Whether the employee has won any awards. You know, they get employee awards, right? Weekly awards, performer awards. If he has employee has won the award, it will be 1. If the employee has not won the award, it will be 0. 1 means yes, 0 means no. Globally, across data science, 0 always represents no, 1 represents yes. Alphabetical order by default. Until unless specified. Sometimes if it is specified 0 as yes, 1 as no, we have to take it like it. If no specification is given, 0 will always be no, 1 will always be yes. Alphabetical order. Because n comes before y. Got it? Same thing for female and male. Until unless specified, female is always given 0, male is always given 1 because of alphabetical order. F comes before M. But if it is specified that in the data dictionary, they specified that male is 0, female is equal to 1, we will take it as such. Right? So now let us do work on non-numeric categorical data. On non-numeric categorical data, we can do frequency counts and cross-tabulation. On non-numeric categorical data, we can do frequency counts and cross-tabulation. What is cross-tabulation? Cross-tabulation is frequency table of two non-numeric categorical variables. Which one? Not lookup. Crosstabs are different. Lookup is different. Crosstabs are different. Okay. Now, I want to know how many types of education are there. How many types of education are there? HR train dot education dot value underscore counts. The function for frequency is value underscore counts. And if you want to see the NS also, you can add a command called drop NA false. If you want to see the NS also, NS means missing values. You can add a command, you can add an argument called drop NA is equal to false. Or you can run it normally. If you run it normally without drop NA, it will not show you the NS. So bachelor's is 36,669. Masters and above is 14,925. Missing values or NAs are 2,409. Below secondary is 805. Right? So this is the frequency counts of the variable education. Frequency counts of variable education. Now find out the frequency counts of variable gender. Frequency counts of variable gender. Find the frequency counts of the variable gender. HR train dot gender dot value underscore counts. VA and tab will give you the value counts. And you can add this argument drop NA is equal to false. If there are no NAs, it will not show you any NAs. So how many male and how many female? So HR train dot gender dot value counts drop NA is equal to false. There are no missing values. There are no missing values. So 38 is male, 16,000 is female. Frequency count of department. Frequency count of department. So which department has the most highest values? Sales department. You got the sorted order or unsorted order? Sorted order, huh? HR train dot department dot value underscore counts. Sorted order. Sales and marketing 16,840 employees. Operations 11,000. Technology and procurement have same. Analytics 5,352. Finance 2,536. HR 2,418. Right? Now, let us say department-wise genders. Department-wise gender. That means how many male and female are there in each department. We have a function called cross tab. PD dot cross tab. HR train dot department, because department is larger. HR train comma HR train dot gender. Now you can see which department, how many males and females are there. Cross tab is for cross tabulation. This is cross tabulation. Cross tabulation. So department wise, male and female counts. Each department, how many male and females are there? Department wise education. Department wise education. Department wise education. Cross tab is cross tabulation. PD dot cross tab. So PD dot cross tab. HR train dot department comma HR train dot education. You got the cross tabulation of department and education. The arguments are separated by comma. You have given two arguments, they are separated by comma. So there are no below secondary in analytics, right? There are no below secondary in R&D, obviously. There are no below secondary in sales and marketing, right? Below secondary is not there in analytics. Below secondary is not there in R&D. In sales and marketing also, we don't have below secondary. Okay. So you need to analyze which department. Analytics is dominated by bachelors. I think most of the departments are dominated by bachelors, right? Most of the departments are dominated by bachelors. So previous year ratings, frequency count of previous year rating, previous underscore year underscore rating. Frequency count of previous year rating. HR train dot PR dot value underscore counts. Drop NA is equal to false. So we have missing values here. 4,124. One rating, most of them are 3 rating. 5 rating is 11,000, 4 rating is 9877, 1 and 2 are 622 and 4. See, take NS also into consideration. NA means missing value. Missing values, empty cells. In that variable, there are certain empty cells. So what happens is, if there is an empty cell, Python will by default whatever impute NA. In that empty cell, it will impute NA. So NA means it's a missing value. So we have to either remove them or we have to treat them. Treat them means we have to replace them with some other value. If there are NAs, you cannot perform any algorithm analysis. You cannot run any algorithms. So missing values are represented by NA or NAN, not a number. NAN means not a number. So drop NA is equal to false means by default it will drop NS. By default the function will drop NS. That means it will give you the output without NS. But I am saying drop NA is equal to false. That means do not drop NS, show me the NS also. By default is it will drop NS and it will show the remaining. So if I remove this command and run, I'll get the output. But do you see NS? And if you total up, you will see the total does not match. It is not equal to that 53,000. Now what is the difference? Missing values. So to know whether there are missing values or not, we need to add this command called drop NA is equal to false. Then you will see the missing values. In R also we have this function, use NA is equal to always. It will show the missing values. Because we have to treat them, right? We can't have missing values in our data. We have to either delete them or we have to treat them. Deleting is an option if you have very large data. If it is not a large data, we cannot delete, we have to impute them or we have to treat them. While doing data pre-processing, when I'm discussing, I will tell you all the methodologies involved in doing the missing value imputations. Manual methods as well as algorithm methods. See, previous year rating. Now, cross tabulation of previous year rating and gender. Cross tabulation of previous underscore year underscore rating and gender. Cross tabulation. PD dot crosstab HR train dot previous year rating comma HR train dot gender. So you can see here the table, female and male and the ratings. All right. So this is all we can do on non-numeric data. This is the analysis we can do on non-numeric data. Now we will continue in this same file. Okay. So we have completed the first two components of exploratory data analysis. Like I told you yesterday, right? Yesterday we discussed exploratory data analysis. What are the components in exploratory data analysis? In exploratory data analysis, the components include descriptive statistics, data visualization, and data wrangling or data manipulation. See here, descriptive statistics, data visualization, data wrangling or aggregation. We have done descriptive statistics yesterday, univariate statistics, bivariate statistics. And descriptive statistics can be done only on univariate statistics, and bivariate statistics can be done only on numeric data. On non-numeric data, we can do only frequency counts and cross tabulations. We have also done data visualizations, the histograms, the box plots, and the density curves. Now let us get into data wrangling or data aggregation. Data wrangling and data aggregation is also a very critical part of our exploratory data analysis. Now there are two genders we have, female and male. Now the question is asked is, who got higher average training score? Did males get higher average training score or females get average training score? How will you answer this question? A question is asked like this: who performed well in terms of average underscore training underscore score, male or female employees? Who performed well? We have 38,000 male employees, we have 16,000 female employees. Now, how will you answer this question? Generally, we can't compare one to one, right? We have to take the average training score of all the male employees, and we'll take all the average training scores of female employees and divide it by the corresponding number of employees. You will get a value. And then that value can be compared. That value can be compared. This process, we call it as data aggregation. Data aggregation in the back end will split the data frame into as many levels as there. Here we have in gender 2 levels. It will create 2 data frames, male only data frame, female only data frame. Then it will calculate the average of the average training score of male. It will calculate the average of average training score of female, and then it compares those averages. It gives us those averages, not compares. It provides us those averages. This whole process is done by the group by function in the backend. In the backend, the group by function will split the data frame into the as many levels, and then correspondingly it will calculate the averages. So for answering this, HR train dot average training score dot group by, the function name is group by, HR train dot gender dot mean average comparison. So on an average, females got 63.88, males got 63.17. So for the group by function, left side of group by is always numerical. Left side of group by is numerical. Right side within brackets of group by, within brackets of group by is categorical. Categorical means what? Non-numeric, right? And a statistical function must be specified. A statistical function must be specified. Now the statistical function can be median, it can be standard deviation, it can be skewness, it can be kurtosis, it can be mean, etc. This is the syntax of group by function. The left side of the group by is always numerical. The right side of the group by within the brackets is categorical. And you must specify a statistical function. The statistical function can be mean, median, sum, it can be count, it can be standard deviation, it can be skewness, it can be kurtosis. It can be any statistical function you want, you have to specify. This is the standard syntax of group by function. So in the back end, it split the data into two data frames and calculated the average training scores of each of the data frames. So the group by function is a very important function in data aggregation. It aggregates the data based on a categorical variable. The categorical variable here is gender, right? So it does the complicated process. Before group by, we used to separate the data into two and then we used to calculate the means. Now we don't need to do that. The group by function will do it for us, right? 63.88 is the average training score of female. So who is performing better? Females are performing better than males. Now answer this question. What is the median age of male and female employees? What is the median age of male and female employees? Median age of male and female employees. What is the numeric variable here? Age. What is the categorical variable? Gender. So age should be first, followed by gender. Okay. What is the age? Female, how many age? What is the male? Same. Both of them are same. HR train dot age dot group by HR train dot gender dot median. 33 and 33. Median is 33. I think mean we will get a slight difference. Mean also almost similar. 34.99 and 34.72. So not much of a difference between the male and female ages. What is the average underscore training underscore score for different previous underscore year underscore rating? So what is the average underscore training score for different previous year ratings? What is the average training score for different previous year ratings? So numeric variable is what? Average training score. Previous year rating must be treated as categorical, non-numeric. So HR train dot average training score dot group by HR train dot previous year rating dot mean. So one rating is 60, 61 for two rating, 64 for three, 64 for five, four rating, 63 for five rating. 3 and 4 are having high because majority are there. Na? Number of employees who got 3, 4 ratings are more compared to the one who got 5 ratings. What is the average length underscore of underscore service of different previous underscore year underscore rating? Average length of service. Average length of service. Average length of service is also a variable numerical. How many years the employee is with the company? All are around 6. All are around 6. So that is also not a differentiating variable. In dot length of service dot group by HR train dot previous year rating dot mean. 6.22, 6.24, 6.30, 6.19 and 6.26. So this is also not differentiating factor. So we have to explore the data further. On what basis people are getting promoted? So length of service rating is not there. Oh, we have forgot is underscore promoted here. The dependent variable is underscore promoted. Dependent variable in this data is underscore promoted, which is in the form of 0, 1, which is no, yes. Do the value counts. Find the frequency of is underscore promoted. The dependent variable, I forgot completely, sorry. Is underscore promoted is the variable, that is the dependent variable, which is in the form of no and yes. Find the value counts. How many employees got promoted and how many didn't get promoted. Dot value counts. Yeah, 10% of the employees generally get promoted in an organization, right? So HR train dot is underscore promoted dot value counts. So 50,000 didn't get promoted, 4,668 got promoted. Now, what is the average training score? Average underscore training underscore score of is underscore promoted 0 and 1. Both are 71. Na? For one is how much? 62. So training score of promoted employees is higher. So that signifies our variable HR train dot average training score dot group by HR train dot is underscore promoted dot mean. Yes. So people who got promoted got higher training score. Now, is the length of service? What about the length of service? What is the average length underscore of underscore service of is underscore promoted 0 and 1? Morning. Okay. Oh, non-promoted guys are higher, having a slightly higher. Okay. Which are train dot length of service dot group by HR train dot is underscore promoted dot mean 5.87 and 5.71. Now we can also give two categorical variables. Two categorical variables in group by function. We can also give two categorical variables in group by function. Take for example, what is the average underscore training underscore score of is underscore promoted and gender. Is underscore promoted and gender. So here we have three variables. Average training score, which is numerical, and two categorical variables, is underscore promoted and gender. So let us do that. HR train dot average training score dot group by square brackets, within square brackets, multiple arguments. If you remember, multiple arguments have to be given in square brackets. HR train dot is underscore promoted, comma, yeah, and dot gender dot mean. Okay, we can give maximum up to 3 categoricals. Beyond 3 categoricals, it will not make sense. So promoted female in one almost 71, right? 71.99 female, 71.01 male. So female has slightly higher training scores within the promoted category. Okay. All right. So we'll stop here. We'll take a break for 15 minutes and then we'll come back. You want me to send this notebook? AV? AV means analytics with that. Yeah. We'll add. Now you want, or you want me to send at the end of the session? End of the session, I can send. We will add more. So AV analytics. Okay. Take your break, please. Online guys, we are taking a break of 15 minutes and we'll be back at 11:15. Okay.
Hello.
See, when you have the special characters and all in your name, now don't use dot. If there is a space, don't use dot. If there is a special character, don't use dot. Right? Use the square bracket single quotes. So, square bracket single quote should be used for accessing a column if there is a space in the column name or if there is a special character associated with the column name. Here question mark is there. That is why dot is not reading the name. So when dot is not working, you have to use square bracket, single quote and a variable name. And when you're copying paste the variable name, please make sure you don't copy the empty spaces before and after. Exact variable name you have to copy. Got it right? About one. So one promoted is 4.88 length of service. In not about one and promoted, 5.82 is the length of service. Can you go through and see, can anybody generate any other information? How can we add any question? Just go through the variables. Give me one question from your end. Number of trainings for recruitment channel. Okay. What is the average number? NO. NO underscore of underscore trainings for different recruitment channel underscore channel. Find out. Hey, instead of average, we should use median, right? Or we use average. Okay, we use average. Let us see. Got the output. What is the average trainings? HR train dot number of training dot group by HR train dot recruitment channel dot mean. 1.25, 1.19, 1.24. Actually, median makes a sense here, right? You cannot have this thing. So median makes a sense. All of them have one training, but again, they all one. Right? They all went through one training. So number of trainings is not the right variable. Any other numeric variable? Actually, this data has limited numeric variables. That is also categorical, no? 0 and 1. Yes or no? But anyway, let's, for learning purpose, we will do this.
What is the average number of trainings to get promoted?
That you can do. For he is promoted, you can do.
So how many awards one to get promoted?
That also we can do. Yeah, which regions has more promotions? You can do that also. Cross tabulation. You have to do cross tabulation. Do that. Hey, do cross tabulation of gender and is promoted. And is promoted. Cross tabulation of gender and is promoted. Cross tabulation of gender and is promoted. Is underscore promoted. No, you have to appropriate. See, you have to understand something called proportionate table. Prop table in Python. How to make Python cross tab with percentage. Normalize is equal to index. Normalize is equal to index. So see, he is saying males are got promoted. Most of the males are got promoted, right? The actual number sometimes deceptive. HR train dot is underscore promoted, comma HR train dot gender. Okay. So 3,201 males are promoted and the male category is dominant. Obviously, number of promotions will be there. Female categorization is less. Obviously, number will be less. So we can't compare number to number here. What we have to compare here? We have to compare percentages. How much percentage of females are promoted? How much percentage of males are promoted? If percentage of females are promoted or more, then we can say females are more working more for the organization, even though number is less, but the proportion of thing is very important, right? So see, when you have uneven populations, if had there been equal number of males and females in our data, we can do this number to number comparison. But here there is a drastic difference, right? Females more than double, males are more than double the females, right? 32,000 something. So we can't, obviously 32,000 by 35, how much you'll get? A total male population is how much? We have done the frequency count, right? 38,496, right? 3201 divided by 38,496, 8%, 8.3% is the promotion in males. Same thing, what is the total females? No, total females count 16312. So 1467 divided by 16312, 8.9%. So who are performing better? Females. So the proportions are very important here. How many proportions are there? So to get the percentages or proportions, we'll copy the thing. We have this command call, comma, normalize is equal to true. So overall, you got 100%. The table is 100%. So 5% and 8%, you're getting it. Normalize is equal to true. This also is not giving us the right picture, right? Only promotion percentage it is giving us. But you compare the population versus proportion, females are better than the males. This is okay. Normalization, instead of normalization, do we have any other? So we have apply lambda r dot sum axis is equal to 1. Let us do this. What we get here. Yeah, it is saying 68% of females got promoted, 31% of females got promoted. But actually, this is also not the right representation, right? This is the actual number representation. Any other method is there? We need to get it that length df. This is giving the same. Go. See, basically what I am trying to say is proportion of females promoted. So what is the total number of females promoted is 1467, right? Print 1467 divided by what is the total number of females? 312. Print 3201 divided by what is the total male population? 38496. 8.33 and 8.9. So if you round off this, got it in percentage terms, right? Females and males promoted to respective populations. See, 8.99 females are got promoted. Almost 9% females got promoted. Only 8.3% males are promoted. But if you see the male number, actually it is higher. So the proportions are very interesting aspect. So this gives us the right representation. We can't simply say females are not, based on the actual numbers, females are less promoted. But compare it to their actual population, they are 9% promoted. Only 8% of males are promoted. Because if you round off, this will be 8, right? Less than 0.5, it will be 8. This will be 8.99 will be automatically rounded off to 9. So 9% of the females got promoted, 8% of the males only got promoted. So who is best performing? Females are best performing. But actual number says the different story. These type of data traps we should avoid. Let us add a decorator. Percentage of females promoted this is called decorator. Okay, so that we know the actual thing. We will talk about decorators when we talk about Python programming. Till the time, right, use this decorators. Right? Now there is no doubt. You can add the statement to the percentage of females promoted is 8.99. You want, you can add np dot round also. Np dot round. Dot round function, okay? 8 and 9. This gives you the clear thing. So females are more performing than males in the organization. You can do this. I'll come in a minute. All right. So this sort of analysis, a lot of exploratory analysis we are doing. So let us say similarly, we can also look at the proportion of promotions in departments. The proportion of promotions in departments. So we can use PD dot crosstab HR train dot department, the larger one on the rows, comma HR train dot is underscore promoted. We need the total also. So can give PD crosstab gives us the total. Row total. How do we get the row total? 1 second. So margins is equal to false. What is margins? Add row or column. Margins is equal to true. We have to add margins is equal to true. Margins is equal to true. Right? We got the row totals. Now all we have to do is the proportions. Right? How do we get the proportion? Any other command is there? Margins name normalize. Normalize is there. So if passed all are true, will normalize our values. If passed index will normalize over each row. If passed columns will normalize each row. So normalize is equal to index. Normalize is equal to index. Let us try normalize is equal to index, comma. So margin is equal to true, added the row total. Okay. Normalize is equal to index. So 9% we are getting what you call promotions, right? 9% in analytics, 8% in finance, 5%, 9% in operations, right? So we'll add np dot round. That will sort all the issues. np dot round. Decimal is equal to 2. Now we can see here. Is equal to 2 into 100. Right? Now we can see the promotions in each department. Technology has 11% promotions, sales and marketing 7%, procurement 10%, operations 9%, legal 5%, HR 6%, finance 8%, analytics 10. Proportion of promotions in department, right? How many people are getting promoted in each department? So we, as part of data analysis, we have to generate information like this. The intelligence has to be generated, and this is what the clients pay you fees for. For you to generate such information using Python or Excel or R or whatever is the software, they want you to generate information. So which department has highest promotions? Technology. Followed by analytics and procurement. Then sales has only 7% promotions. Operations has 9. Legal, obviously, small department, hardly 5% promotions. So we need to understand this sort of analysis. Now you can convert it into graph also. Copy the whole command and paste it in a new cell. You have to add one more bracket. No. Dot is not working. One bracket also. Dot plot kind is equal to bar. Comma tag is equal to converted the information into stack bar plot. So first add square round brackets to np dot round to 100. Okay, first add round brackets here and here. Then add the plot command. Okay. So margins is equal to true means it will do row totals. Okay, margins is equal to true is row totals. Normalize is equal to index means it divides with the row total. Normalize is equal to true means it will give you like old table, all percentages. That is not what we require. We require the row total. Row number divided by row total. That's why we use normalize is equal to index. It is recording. Yeah, it's recording. Here now you can see the dot, red dot. It is recording. Okay. All right. Any doubts in this cross tabulations? These are very important. So proportions, be careful. Particularly when you're working in sales data or HR data, procurement data like that, you need to look at the proportions. Very important in such data points. So actually the numbers, you should not go blindly with the numbers. Look at the proportions, right? Now, HR train dot average training score dot describe. HR train dot average training score dot describe. Now the minimum training score is 39. The maximum training score is 99. If you are familiar with Excel, we have a concept called grouping. Grouping is nothing but a frequency distribution table, right? 1 to 10, 11 to 20, you create these groupings and then you create the bins. And using that bins, we will count how many people are there in that particular category. So in our case, we can say 31 to 40, 41 to 50, how many employees code. We can create a frequency distribution table like that. Now we can know it using histogram also, but sometimes histogram doesn't give you data label, right? If you want a data label based thing, so you have to do the grouping. So for grouping, all of you go to Google and say pd.cut. I want you also to get familiarized with the documentation. pd.cut, pandas cut. Cut is a function that helps us to bin values based on discrete class intervals. Just study this one. So bins, you can give it as a sequence of numbers, data, labels is equal to none, precision 3. So we have a lot of functions here, which we have to use. So qcut will do quartile cut, divide it into equal parts, but we don't want it in equal parts. We want to give it as a proper thing. So we can add labels also. So how many bins we will try? Let us try. Okay, all of you go through this code once, including this. In the bottom, you can see the examples. So shall we cut it into 3? Good training score, average training score, and bad training score. Bad, average, and good. 3 categorizations we can do, right? Let us do that. pd.cut np.array, because the data has to be given as an array. What HR train dot average training score, comma 3, comma labels is equal to bad, average, good. Okay. But why it is showing like this? Bad average, bad average. We have to see the output. Dot value counts, I think we have to do. Oh, category object. Oh, sorry. Yeah. Dot value counts we got. So good training score, we got this. If we want the range also, what should we do? What should be the numerical range? Ret bins is equal to true. RET bins is equal to true. So 38.9.4. This is the class intervals 38.94, 59, 79, and 99. So how will you get the show? How do we show the output? Just go to the data. It means is equal to 2, right is equal to false. Huh? Just check Stack Overflow. How do we get the bins also? So the bins it has created is 38.4 and all, but we want to know have the categorization as well as the bins. That way it will be good for us, right? We can understand the binning also as well as the labels. Actually, we have to add the column and then only we can see. We have to add the column and then we can see. Right? So bad average training score, 25,000 employees, what average is 18,000, good average training score is this. The bins, what it has given us is, if you take out the same command, red bins is equal to true, you can see here, 3894 to 59, 59 to 79, okay? And then 79 to 99, the bins. Now we can do value counts here. Oh, tuple has no attribute value count. So it's a tuple actually we are getting. Okay, we are getting it as tuple, round brackets, na? We are getting it as tuples. Square brackets is arrays and lists, tuples is round brackets. But we can add it as a column. So let us say HR train square bracket single quote bins square bracket equals to. Oh, right is it? Length of values does not match index of 54,808. Okay. What is right? Okay. Right is equal to true is there, yeah. Yes. Let me just see. Red bins equal to true. No, right is equal to true. Okay, got an error. Yeah. So, okay. Sorry. Again, we can broaden the range also with the intervals, with our own interval range. We can give our own interval range. Try if you can change the interval range somehow. I will also look for it. So we can do We can define our own bins actually. Let us do with bins definition. Bins is equal to square bracket. Lowest score is how much? 39. Okay, so we'll start with what? 39 to 49? No. How will we get the bin? 39, 49, 59, like that will go? Will that be okay? 39, 49, sorry. 59, 69, 59, 59, and 99. Maximum is 99, right? HR train, square bracket, single quote, bins is equal to PD dot cut HR train dot average training score, comma, bins. HR train dot bins dot value underscore counts. Yes. Okay, but 39 is missed. I think we have to add 29 also. Dot sum. Is the total count 54,088? Huh? Then we are correct. That is equal to we are not getting the order of the chaos intervals. We are getting the order of the values. Most of the scores are between 49 to 59. Most of the employees scored between 49 to 59, 59 to 69, 11,000, 79 to 89, 9,760. So how do we order the bins? Ordering bins also will help us, no? The ordered is equal to false. Sorry. Labels must be provided if ordered is equal to false. Okay, so this is how we got the bins. sort underscore index. We got it. Very simple. Sometimes the simplistic solution also will create. Now we got the bins correctly. 29 to 39, 39 to 49, 49 to 59, 59 to 69, 79, 89, 99. Right? Bins have been sorted now. Do the same analysis for length of service. I would like all of you to do the same analysis for length of service. Length of service. Similar analysis on length of service. What is the minimum? Huh? 1. What is the class interval you are taking? Huh? What is the max? So 1, or you take from 0, 5, 10, 15, 20, 25, 30, 35. That would be better, na? 5 class interval starting from 0. 0, 5, 10, 15, 20, 25, 30, 35, and 40. So we will do bins is equal to square bracket 0 comma 5 comma 10 comma 15 comma 20 comma 25 30 35. Maximum is 40, right?
36.
No, that's what 40, the next outer limit. So HR train square bracket single quote service bins. Okay, I'll name it as service bins is equal to PD dot cut HR train dot length of service comma bins. HR train dot service bins dot value underscore counts dot sort underscore index. 0 to 5 mostly 30. Oh, 35 to 40 only one is there. If you say 35, will that be added to 44? If you restrict it to 35, no, it is not adding it, right? So we have to have that 40. Then we need to have more than, something called more than has to be there. Okay. So this is a type of analysis which you can do on numerical data, converting it. What we are basically doing is we are creating frequency distribution tables, and we understand the performances of different what you call employees in the organizations. Okay, so we have worked on this data. What else can be done? EDA, what is left out? Grouping we have done, manipulations we have done. KPIs, that is yes or no only, 0 and 1. Something I forgot. Okay, so we have here both numeric variables and non-numeric variables, right? In the info, we have both numeric variables and non-numeric variables. So we have age is numerical, number of trainings is numerical. Okay. Then previous year rating, we are considering it as categorical. We are not considering it as numerical. Length of service, we will consider it as numerical. KPS met 0 and 1, yes or no, again categorical. Awards 1, yes or no, categorical. Then average training score is numerical. He is promoted, again categorical. It is 0 in 1. 0 means no, 1 means yes. So let us say HR train dot columns. Sorry. Now we will do correlation analysis on the numeric variables only on numeric variables. So HR train double square brackets. So what is the number of trainings is numerical, age is numerical, control C, control V, comma, length of service is numerical, length of service is numerical, control C, control V. Then which one? Awards 1 is again 0 and 1. Average training score, numerical. These are the numerical variables, right? Dot COV, covariance in the matrix form. For multiple numeric variables, we are doing covariance. So we'll copy the same data down dot CORR, correlation. 65 is there. Between length of service and age, we have a strong moderate correlation, 0.65. So multiple variable scatter plots in SNS it is possible. Import Seaborn as SNS. SNS dot heat map. Put this code. Comma, because this heat map we need the values, right? Okay. SNS heat map. Not is true. ANNOT is equal to true. Get the values. You get the values for the correlation matrix. So length of service and age has moderate correlation. Rest of all have no correlation. Heat map, correlation heat map. For large data, we use this correlation heat map. And NOT is equal to true will give you the correlation values in the box. All right. So you experiment with the other data set. Amsterdam data set is there. No? So if you are interested, you can download Chicago or other city and you can practice. We have, I think, no class this week, right? From next week onwards will be okay. You will come Monday, Tuesday, Wednesday, and Friday. Right? 4 days in a week. Monday, Tuesday, Wednesday, and Friday. Huh? After some time when my academic classes starts, it will be Monday, Wednesday, and Friday only. As of now, summer internships are going on, so I can give you 4 days. Thursday, I have another session, so that's why it's not possible. Okay. So it's better for you to have to practice time also, right? So you will have practice also. I keep on giving you the data sets. Whichever data set you like, you work on it with an agenda that you should be able to upload it in your GitHub. You choose your data sets. Okay. I think this can be uploaded as exploratory data analysis. We have done a lot of EDA here, right? So you can put it as a EDA. No. Don't see if you can explain this, then upload. I don't have any problem. Huh? No. There is no admin or nothing. I'll just send you the IPNB file. You can upload it. There's no. I am not going to upload it to any GitHub or anything like that. It will be there. The problem is you should be able to explain the concept there. That's why I'm insisting. If you are okay, you read the file and you understand what we are doing. Then if you ask him to explain what Q cut you have done, how it you have done, if at all you missed the Q cut in the session, then it will be difficult, right? So that is the reason why I insist on you to have your own files being there. Add your own notes, methodology, how you have done it, how you fixed the bins, just one line, and then, or you can upload this notebook. I don't have any issues. So I'll stop the recording.